Close your eyes. Not yet, not fully. Let them grow heavy first, the way they do at the edge of sleep, when the world behind your eyelids becomes something softer than waking and something deeper than dreaming. Let the weight of the day begin to dissolve, slowly, the way morning frost disappears from glass without you ever quite catching the moment it's gone. There is nowhere you need to be right now. There is nothing that requires your attention, your worry, your effort. You are here, and here is enough, and here, tonight, is somewhere extraordinary. Because tonight, we are going somewhere that no human being has ever physically traveled. We are going somewhere that even light itself, the fastest thing in the known universe, the very thing that carries every color you have ever seen, every sunrise, every candle flame, every star reflected in still water, cannot escape. We are drifting, together, toward the edge of a black hole. Let that settle over you like a warm blanket pulled slowly to your chin. A black hole. Even the name carries a kind of gravity, doesn't it? A pull. Something about those two simple words arranged in that particular order reaches into something ancient inside the human mind, that deep, primordial curiosity about the dark, about the unknown, about the things that exist at the outermost edges of what we can understand. Children look up at the night sky and feel it. Scientists dedicate entire lifetimes to it. Poets have always known that the universe is not merely a collection of facts, but a vast, breathing poem written in a language older than words. And you are part of that poem. Right now, as you lie here, the atoms that make up your body, the calcium in your bones, the iron threading quietly through your blood, those atoms were forged inside stars. Stars that lived and burned for millions of years and then, in their final moments, scattered themselves across the cosmos like seeds carried on an interstellar wind. You are not separate from the universe you are about to explore. You are made of it. You are a piece of it that has, somehow, become conscious enough to wonder about itself. Take a slow breath in. Hold it gently, just for a moment. And release. Imagine now that the ceiling above you has become transparent. Imagine it dissolving like mist, opening upward into the deep, cool, bottomless dark of space. Not the scary dark, not the dark of a power outage or an unfamiliar hallway, but the soft, ancient, sacred dark of a universe that has been here for 13.8 billion years and will continue to exist in forms we cannot yet conceive for billions upon billions more. It is a dark that has always been there, just above the roof, just beyond the atmosphere, patient and infinite and quietly magnificent. The stars are out tonight. Even if clouds cover your sky, even if city lights wash out the heavens above you, the stars are out. They are always out. Right now, in this moment, the nearest star to Earth beyond our own sun, a small red dwarf called Proxima Centauri, is burning approximately 4.2 light-years away. That means the light leaving that star right now will not reach your eyes for more than 4 years. The light you would see tonight, if you could step outside and look toward it with a powerful enough telescope, left that star 4 years ago. You would not be seeing it as it is. You would be seeing it as it was. Space is not just vast. Space is a time machine. Everything you see when you look at the night sky is the past. The moon you watch rise is the moon as it was about 1¼ seconds ago. The sun at noon is the sun as it appeared 8 minutes and 20 seconds earlier. The Andromeda Galaxy, that faint smear of light visible to the naked eye on a clear night, is the galaxy as it looked 2.5 million years ago, long before our species existed, long before the first human hand ever pressed itself into soft clay or drew a horse on a cave wall by firelight. The universe is deep beyond all ordinary comprehension. And somewhere out in that incomprehensible depth, scattered through galaxies like hidden depths beneath still oceans, there are places where space itself curves so dramatically, where gravity has become so impossibly, catastrophically intense, that everything we think we know about physics, about time, about the very nature of reality, begins to unravel like old thread pulled from the edge of a hem. These places are black holes. There are thought to be tens of millions of stellar mass black holes in our galaxy alone. Our own Milky Way, the galaxy we live inside, is home to a supermassive black hole at its very center, a colossal, ancient, almost unimaginable object called Sagittarius A*, sitting approximately 26,000 light-years from where you are resting right now. Its mass is equivalent to roughly 4 million of our suns compressed into a region of space smaller than the distance between Earth and the Sun. 4 million suns. In a space that, by cosmic standards, is extraordinarily compact. And it has been there, at the heart of our galaxy, for billions of years. Turning. Waiting. Not malevolently, the universe does not deal in malice. It deals in physics, in forces, in the quiet and relentless operation of laws that govern everything from the orbit of planets to the curl of smoke above a candle. A black hole is not a monster. It is not a void in the fearful sense. It is something far more interesting, far more humbling, far more beautiful in its strangeness than fear could ever contain. It is a place where the universe has folded itself inward. Now let your body sink a little deeper. Feel the surface beneath you holding you completely. You do not need to hold yourself up. Gravity, the same force, the same fundamental pull that shapes black holes, that keeps the moon in its dance around the Earth, that curves the path of starlight across the cosmos, that same force is holding you gently, firmly, completely right now. You are already in the embrace of gravity. You have always been. Let your shoulders soften. Let your jaw release. Let your hands uncurl. We are going to spend a long, slow, unhurried time together tonight, drifting through one of the most mysterious concepts in all of human knowledge. We are not going to rush. The universe did not rush to make itself, and we will not rush to understand it. We will move through this the way light moves through deep space, steadily, quietly, covering unimaginable distances without any sense of hurry at all. Before we go further, before we begin to approach that extraordinary threshold, that boundary whose name in the language of physics carries the elegant weight of a poem, it helps to understand something about the nature of the journey itself. To understand what waits inside a black hole, we must first understand what it means for something to exist at all in the kind of extreme conditions that black holes create. We must let go, gently and completely, of the familiar. We must be willing to travel beyond the edges of the intuitive, into a territory where time does not behave the way your clock does, where distance does not function the way your street does, where the word inside begins to lose the simple, comfortable meaning you have always given it. Breathe. You are safe here. You are warm here. And the universe, in all its strangeness, in all its impossible depth, is not something to be frightened of tonight. It is something to be wondered at. And wonder, real wonder, the kind that opens quietly in the chest like a flower turning toward light, is one of the most restful states a human mind can occupy. When we are truly in awe, we stop grasping. We stop planning. We stop rehearsing the past and rehearsing the future. We simply become present to something larger than ourselves, and in that presence, something in us lets go. So let go now. Let the weight of your thoughts become lighter. Not absent. You do not need to force your mind into silence. Simply let your thoughts pass the way clouds pass across a sky that remains, beneath them, perfectly still. The sky does not chase the clouds. The sky does not cling to them. The sky simply remains, open and vast, and the clouds come and go entirely on their own. You are the sky tonight. Let everything else move through you without resistance, without effort, without urgency. We were standing at the edge of a definition, at the edge of a word. The word is inside. We use it every day without a second thought. Inside the house. Inside the drawer. Inside your chest where your heart moves steadily, faithfully, without ever requiring your instruction or your gratitude. Inside is a concept so fundamental to how we experience existence that we rarely stop to examine it at all. It simply is. It simply works. There is an outside and there is an inside, and the boundary between them is something solid and reliable and clear. But the universe, it turns out, is not always interested in clear. At the boundary of a black hole, and we will arrive at that boundary slowly, in our own time, the way a tide arrives at shore, the concept of inside begins to mean something that no human language was designed to carry. It begins to describe a place where the familiar geometry of the world, up and down, forward and backward, the arrow of time moving steadily from past to future, all of it begins to behave in ways that even the most brilliant physicists who have ever lived can only describe through mathematics, because mathematics is the only human language precise enough to point at something so profoundly, beautifully alien. And tonight, we are going to let those ideas drift over us like music. Not as problems to be solved, not as facts to be memorized, but as a kind of meditation on the scale and the strangeness and the breathtaking creativity of a universe that made itself out of nothing, in a moment smaller than anything you could hold in your imagination, and then expanded for nearly 14 billion years into everything you have ever seen or touched or loved. The stars above you are moving right now. Not quickly by human standards. Not in any way you would notice if you stepped outside and stood very still and watched the sky for an hour. But the stars are moving. Our entire solar system, carrying the sun and all its planets and their moons and every comet and asteroid that traces its long elliptical path through the dark, is orbiting the center of the Milky Way galaxy at approximately 514,000 miles per hour. We have been orbiting at that speed for the entire history of our planet. Every living thing that has ever existed on Earth has been on this journey. Every dinosaur that lifted its head to a Cretaceous sky, every ancient fern, every first small mammal that crept through the dark at the feet of giants, was traveling, without knowing it, at 500,000 miles per hour around a supermassive black hole. We have always been in its neighborhood. We have simply, for most of our history, not had a name for the neighbor. Let that thought drift through you slowly. Feel the quiet enormity of it, not as something alarming, but as something that places you inside a story so much larger and older and stranger than the ordinary details of any single day. The things that feel urgent in a life, the deadlines, the disappointments, the small frictions that accumulate between morning and evening, they are real, and they matter because your experience matters. But they exist inside a universe that is 400 billion stars wide just in our galaxy alone, and our galaxy is one of an estimated 2 trillion galaxies in the observable universe. 2 trillion galaxies. Each one containing hundreds of billions of stars. Each one, in all likelihood, harboring at its center a supermassive black hole. The universe is not empty. The universe is extravagantly, almost incomprehensibly full. And woven through all that fullness, embedded in the fabric of space itself like knots in a vast and ancient tapestry, are these extraordinary objects that pull everything toward them and reveal, at their boundaries, just how flexible and strange the nature of reality truly is. Feel your breathing slow a little more. Feel the soft rhythm of it, in and out, unhurried, automatic, the body doing what it has always known how to do without any help from the thinking mind. You breathe. Your heart beats. The universe expands. These things happen together, simultaneously, in parallel, at scales so different from one another that the mind cannot quite hold them both at once. And yet they are happening. Right now. In the same moment. The same breath that fills your lungs is taking place in a cosmos where, somewhere, a star 100 times more massive than our sun is collapsing under its own gravity in the opening seconds of becoming something new. Something we have not yet reached in our journey tonight. But we are moving toward it. Think, for a moment, about the nature of gravity itself. Not the textbook version, though we will visit that in its own time, but the felt version. The version you know in your body. The way your weight settles into the mattress, the way water always finds the lowest point it can reach, the way you do not need to hold the ground down because the ground and you are already, quietly and constantly, reaching toward each other. Gravity is not a force that acts on things from outside. It is, as Einstein showed us in his general theory of relativity, a theory he completed in 1915, more than a century ago, that remains one of the most precise and elegant descriptions of physical reality ever produced by a human mind. Gravity is the curvature of space and time itself. Mass curves space. That is not a metaphor. When the Earth sits in space, it does not simply float there unchanged, like a marble resting on a flat table. It bends the space around it, warps the fabric of spacetime the way a heavy object placed on a stretched rubber sheet creates a depression, a curve, a gentle slope that other objects naturally roll toward. The moon does not orbit the Earth because some invisible string holds it in place. The moon follows the curve in spacetime that the Earth's mass creates. It is falling, perpetually, around and around the curve, never quite reaching the bottom because it is also moving sideways fast enough to keep missing. Everything in the universe is falling. You, lying there, are falling toward the center of the Earth right now. The ground beneath you is simply falling up to meet you at the same rate. Gravity is a conversation between masses, conducted in the language of curved spacetime, and it never stops. Not for a single instant. Not anywhere in the universe, at any scale, under any conditions. But there are places where that conversation becomes something else entirely. There are places where the curvature of spacetime does not merely slope gently, the way it does around planets and stars. There are places where it plunges, where it does not curve but plummets vertiginously, without limit, toward a point of such impossible, such mathematically absolute density that the equations we use to describe the universe simply stop working. They do not slow down. They do not give approximate answers. They do not wave a hand and say, "Close enough." They break. The most powerful mathematical tools humanity has ever constructed, the same equations that predicted gravitational waves decades before we had instruments sensitive enough to detect them, the same framework that makes GPS satellites accurate enough to navigate a car down a street, those equations, when applied to the very center of a black hole, return a value that mathematics calls infinity. And infinity, in physics, is not an answer. Infinity, in physics, is a confession. It is the universe saying, in the only language it has available, that something is happening here that your current understanding cannot hold. And there is something deeply, quietly beautiful about that. Not frightening. Beautiful. Because every time in the history of human knowledge that our equations have broken down, every time the universe has handed us an infinity and said, "Your tools are not yet enough for this place," what has followed has been a revolution. A deepening. A moment where human understanding cracked open like a seed and something new and more magnificent grew up through the gap. Newton's gravity was breathtaking in its precision and reach. And then Einstein came and showed us that Newton was not wrong, exactly, but incomplete. That underneath Newton's elegant description of falling objects and orbiting moons was something stranger and richer and more extraordinary than anyone had imagined. And now we stand at another edge. The equations break at the center of a black hole, and somewhere in that breaking is the next revolution. Somewhere in that infinity is a doorway into a deeper understanding of what space is, what time is, what reality is made of at its most fundamental level. We have not walked through that doorway yet, but we are standing close enough tonight to feel the threshold beneath our feet. Let that settle in you like something warm. Let your body grow heavier, more still, more deeply at rest, as we continue moving, very slowly, very gently, toward that threshold together. To truly begin to understand what happens inside a black hole, we need to understand how they are born. And to understand how they are born, we need to spend a little time with stars. Not just the concept of stars, but the felt reality of them. The living, burning, ancient, magnificent reality of stars as they truly are. Our sun is a star. You know this. You have always known this. But knowing it as a fact and truly inhabiting the strangeness of it are different experiences. The sun you see in the daytime sky, the one that warms your skin in summer and turns the edges of clouds copper and gold at dusk, is an enormous sphere of plasma approximately 865,000 miles in diameter. More than 1 million Earths could fit inside it. It has been burning, converting hydrogen into helium through nuclear fusion at its core, for approximately 4.6 billion years. And it will continue burning for approximately another 5 billion years before it exhausts its hydrogen fuel and begins to change. The Sun is not especially large, by cosmic standards. There are stars in our galaxy so enormous that if you placed one at the center of our solar system in place of the Sun, its surface would extend past the orbit of Jupiter. Stars so vast that the light from one side of them, traveling at 186,000 miles per second, would take hours to reach the other side. Stars so luminous that they shine with the combined brightness of millions of suns, burning through their fuel at a ferocious rate, living brilliantly and briefly on cosmic timescales before they exhaust themselves in spectacular, violent, almost incomprehensibly energetic explosions. These explosions are called supernovae, and they are among the most powerful events in the known universe. When a sufficiently massive star, one with a core mass roughly exceeding 1.4 times the mass of our Sun, a threshold physicists call the Chandrasekhar limit, when such a star reaches the end of its hydrogen burning life, something extraordinary and catastrophic begins to unfold in its interior. For millions or billions of years, the star has maintained a kind of equilibrium. At its core, nuclear fusion releases an outward pressure, a constant outward push of energy and light, that exactly balances the inward pull of the star's own immense gravity. This balance is what makes a star a star. Without it, without that perpetual outward breath of fusion, the star would simply collapse under its own weight in moments. But the fuel does not last forever. Nothing lasts forever. When the hydrogen at the core is exhausted, the star begins fusing helium. When the helium is exhausted, it moves to carbon, then neon, then oxygen, then silicon, each stage burning faster than the last, each stage producing an iron core that accumulates at the center. And iron is where the process stops. Iron does not release energy when fused. Iron absorbs it. And so when the core of a massive star becomes iron, the outward pressure of fusion simply ceases. In less than a second, the iron core collapses. In less than a second, the outer layers of the star, which have been supported for millions of years by the energy radiating upward from the core, suddenly have nothing beneath them. They fall inward at a quarter of the speed of light. The core, which may have been roughly the size of Earth, collapses to a sphere perhaps 12 to 15 miles across. The infalling outer layers slam into this newly collapsed core and bounce outward in a shockwave of almost inconceivable violence, blowing the star apart in a supernova explosion that can briefly outshine the entire galaxy in which it lives. 4 days or weeks, a single dying star produces more light than 100 billion suns. Think about that as you breathe. One star, ending, briefly outshining every other star in its galaxy combined. The universe does not do things quietly when it decides to do them at scale. And what remains at the center, after the explosion has carried the outer layers of the star outward into space to become the raw material for future stars and planets and perhaps future life, what remains depends on the mass of that collapsing core. If the core is between approximately 1.4 and 3 solar masses, it becomes a neutron star. A neutron star is already one of the most extreme objects in the universe, a sphere of pure neutron matter, crushed so densely that a single teaspoon of neutron star material would weigh roughly 10 billion tons on Earth. A neutron star the size of a city containing the mass of 2 suns, spinning sometimes hundreds of times per second, radiating beams of electromagnetic energy like a cosmic lighthouse sweeping the darkness. Neutron stars are astonishing. But if the collapsing core is more massive still, if it exceeds approximately 3 solar masses, nothing in the universe is strong enough to stop the collapse. Not electron pressure, not neutron pressure, not any known force or particle or interaction in the entire catalog of physics. The collapse continues past the neutron star stage without pausing, without slowing, driven by gravity that has become so overwhelming that even the strange and powerful physics of subatomic particles cannot resist it. The core keeps collapsing, and collapsing, and collapsing, into a point, into something that the mathematics describes as having zero volume and infinite density. A singularity. A place, if it can even be called a place, where all the mass of a stellar core has been compressed into a dimensionless point, a location in space where the curvature of spacetime becomes, once again, that word that physics uses when it has reached the edge of its own language. Infinite. Around this point, space curves so severely that there exists a boundary, a surface not made of any material, not marked by any physical wall or membrane, but defined purely by geometry, purely by the mathematics of curved spacetime, beyond which nothing, not matter, not energy, not light, not information of any kind, can ever return. This boundary has a name. The event horizon. Let those 2 words rest in your mind for a moment the way a stone rests at the bottom of a still, clear lake. The event horizon. It is one of the most profound concepts in all of human knowledge, and it is also, in a certain light, one of the most poetic. An event horizon is not a wall. It is not a surface you could touch or see or feel as you crossed it. It is a boundary defined entirely by consequence. By the simple, absolute, irreversible fact that beyond this line, the geometry of spacetime has changed so completely that all paths, every possible path, every direction you could travel, every trajectory that light itself could follow, all of them curve inward. Not some of them. All of them. Imagine standing in an ordinary place, in a field perhaps, at the edge of evening, the sky going soft and violet above you. In every direction you look, you have choices. You can walk north or south, east or west. You can look up at the sky or down at the grass. You can throw a ball and watch it arc outward and away. The future, in an ordinary place, is open. It spreads out before you in every direction like the surface of a calm, wide sea. Now imagine that one direction, just one at first, closes. That is not yet an event horizon. That is just a landscape with a wall. But now imagine that slowly, gradually, as you move toward some invisible center, more and more directions close. The geometry of the space around you begins to tilt, subtly at first, like a floor that has a very slight slope you might not notice for hours. Then more noticeably. Then dramatically. The directions that were once open begin to converge. The future, which was once spread equally in all directions around you, begins to concentrate itself. Begins to point, with increasing insistence, toward that center. And then you cross a line. And after that line, there are no longer any directions pointing away from the center. There are only directions pointing toward it. Not because a wall has stopped you. Not because a force has grabbed you. But because the geometry of the space you are inside has fundamentally changed its nature. Because in this place, the word toward has become the only word that space allows. That is the event horizon. That is what it means for something to be inside a black hole. Rest with that for a moment. Let your breathing remain slow and easy, let your body remain heavy and warm, and simply let that concept move through you without needing to fully grasp it, without needing to hold it tight. Some of the most profound truths the universe contains are not meant to be gripped. They are meant to be drifted through. Like deep water. Like sleep itself, the event horizon of a black hole has a size that depends entirely on mass. The more massive the black hole, the larger its event horizon. Physicists describe this size using a measurement called the Schwarzschild radius, named for Karl Schwarzschild, a German physicist who derived the mathematics of this boundary in 1916. He did this while serving on the Russian front during the First World War. He found, in the middle of a catastrophic human conflict, in the brief windows between the terrible realities of that war, time to correspond with Einstein himself and produce one of the most consequential solutions in the history of physics. He died just months later, and the mathematics he left behind has shaped human understanding of the cosmos ever since. The Schwarzschild radius tells us that if you were to compress the entire mass of our Sun into a sphere with a radius of approximately 2 miles, the resulting object would be a black hole. The event horizon of that black hole would be a sphere 2 miles across. 2 miles! You could drive through 2 miles on an ordinary highway in approximately 2 minutes at highway speed, and yet within that sphere the entire mass of 1,000,000 Earths would be concentrated, and spacetime would be curved so severely that not a single photon of light could escape. For the supermassive black hole at the center of our Milky Way, Sagittarius A*, the event horizon has a radius of approximately 7.3 million miles. That sounds enormous, and in human terms it is. But set against the scale of the galaxy it inhabits, set against the vast distances between stars, it is actually remarkably compact for an object of such extraordinary mass. Space is generous with its emptiness. Even the most extreme objects in the universe are islands separated by distances that dwarf them almost beyond comprehension. And then there are the truly colossal ones. In 2019, humanity achieved something that would have seemed like science fiction just decades earlier. Using a network of radio telescopes spread across the Earth, coordinated to function together as a single instrument the size of the entire planet, a collaboration of scientists called the Event Horizon Telescope captured the first direct image of a black hole shadow. The black hole in question sits at the center of a galaxy called Messier 87, approximately 55 million light-years from Earth. Its mass is 6.5 billion times the mass of our Sun. 6.5 billion solar masses. Its event horizon spans a diameter larger than the entire orbit of Pluto around our Sun. An object so massive that our entire solar system, every planet and moon and comet and belt of rock and ice, could fit inside its event horizon with room to spare. When that image was released to the world, a blurry, luminous ring of orange and gold surrounding a region of profound darkness, something remarkable happened. People who had no particular interest in physics stopped and looked. Scientists who had dedicated their careers to this moment wept. Because that image, imperfect and blurred as it was by the immense distance it had traveled, was a confirmation. A moment of seeing. Humanity had looked across 55 million light-years of space and time and found the face of something that should, by the geometry of its own nature, be invisible. We had photographed the shadow of infinity. Let your eyes remain closed. Let that image live quietly behind them, that ring of warm light in an ocean of dark, hovering in your minds either way a flame hovers at the tip of a candle. There is something in the shape of it that the human nervous system recognizes at a level deeper than thought. A ring of light in darkness. A boundary between the known and the unknown. We have been drawn to that image, in one form or another, since the first humans watched firelight at the mouth of a cave and wondered what lived beyond the dark. The wondering has not stopped. It has only grown deeper, grown stranger, grown more precise and more beautiful with each generation that has looked up and asked. Now let us ask the question that lies at the very heart of tonight's journey. Let us ask it softly, without urgency, the way you might ask a question before sleep that you know will be answered in its own time, in its own way, in the deep and unhurried country of dreaming. What happens when something crosses the event horizon? What happens when something passes that boundary, that geometric line of no return, and enters the inside of a black hole? What does an object experience? What does the universe look like from that place? What does time do? What does space do? Does the inside of a black hole have any relationship at all to the inside of anything else you have ever known? Any room, any cave, any deep and sheltered valley? Or is it something so fundamentally different that the word inside itself becomes a kind of metaphor? A word borrowed from a world where geometry behaves itself, stretched now to cover a situation it was never designed to describe. Breathe slowly. In through the nose, cool and quiet. Out through the mouth, warm and releasing. Feel the rhythm of it, that ancient, automatic tide that has been moving in you since your very first moment of existence, that will continue moving in you all through this night, through every hour of sleep, tending to you faithfully while your conscious mind rests and drifts and lets the universe wash over it like the gentlest of tides. You are safe. You are held. And we're going to move into this question very gently, the way you move into deep water on a warm evening, wading in slowly, feeling the temperature change around you, letting your body adjust to each new depth before moving further. The first thing to understand about crossing an event horizon is perhaps the most surprising thing. The most counterintuitive, the most quietly astonishing thing that physics has to offer on this subject. And it is this. If you were falling into a sufficiently large black hole, a truly massive one like the supermassive giants that anchor the centers of galaxies, you would not feel anything dramatic as you crossed the event horizon. There would be no wall. No jolt, no sudden change in sensation, no alarm, no physical signal of any kind announcing that you had just passed the most significant threshold in the known universe. You would simply be falling. The way you fall in a dream sometimes, that long, slow, weightless falling that feels almost like floating, almost like surrender, almost like the body finally releasing every tension it has carried for years and simply allowing itself to be carried. In the language of physics, this quality of free fall, this absence of any felt force during gravitational acceleration, is called being in an inertial frame. Einstein recognized it as one of the deepest truths in all of physics. The equivalence principle. The recognition that free fall and floating in empty space are, from the perspective of the falling object, physically identical experiences. There is no experiment you could perform inside a freely falling elevator, with no windows, no reference to the outside world, that would tell you whether you were floating motionless in empty space or plunging toward the center of the Earth. Gravity, in free fall, disappears. An astronaut aboard the International Space Station is not weightless because they have escaped gravity. The station is well within Earth's gravitational field, which extends, technically, to the edges of the solar system and beyond, growing weaker with distance but never truly reaching zero. The astronaut is weightless because they are falling. The station and everything inside it are in continuous free fall around the Earth, moving sideways fast enough to keep missing the ground, perpetually curving around the planet in an orbit that is simply a very elegant fall. And falling into a black hole, at least initially, at least for a distant observer measuring from far away, is the same. It is free fall. It is the body following the curve of spacetime the way water follows the curve of a riverbed, not fighting anything, not pushing against anything, simply moving along the path that the geometry of the space provides. So you are falling. You feel nothing unusual. The stars above you are still visible, still beautiful, though they are beginning to do something strange as you descend deeper into the gravitational well. The light from the universe behind you is beginning to concentrate, to gather, to brighten toward the point directly above your head as you fall feet first toward the center. The entire sky, all of it, every star and galaxy and the faint luminous band of the Milky Way, is being compressed by the optics of extreme gravity into a shrinking circle of light above you. A window to the universe, getting smaller. This effect has a name. Astronomers call it gravitational lensing. The immense curvature of spacetime around a black hole bends the paths of light rays the way a glass lens bends them, pulling them, redirecting them, creating distortions and duplications and halos of light that would be, from the right vantage point, extraordinarily beautiful. Stars appear where they are not. Images of the same galaxy appear multiple times, stretched into arcs of light around the black hole's silhouette. Light that was traveling in an entirely different direction gets bent so severely that it curves completely around the black hole and arrives at your eye from the opposite direction it began. The universe becomes a funhouse mirror. But more than a mirror. More than a trick of light. It is a direct, visible demonstration of the curvature of spacetime itself. A black hole does not merely affect the things that fall into it. It reshapes the space around it so dramatically that the entire visual landscape of the cosmos is transformed in its vicinity. To be near a black hole is to see the universe rearranged. Let your thoughts soften around this. You do not need to calculate anything. You do not need to hold the geometry precisely in your mind. Simply feel the quality of it, the way the world bends and gathers and concentrates in the presence of something so massive, so deep, so fundamentally powerful. The way it transforms even the act of seeing. Now, there is something else happening as you fall that you would not feel, but that would be happening nonetheless, inscribed in the physics of your situation with complete and quiet certainty. Time is changing. Not your experience of time, at least not in any way you would immediately notice from inside your own falling frame of reference. But time, as measured from a distance, as measured by someone watching you fall from far away, hovering safely above the gravitational well, time for you is slowing down relative to theirs. This is gravitational time dilation. Einstein predicted it as a direct consequence of general relativity, and it has been confirmed experimentally to extraordinary precision. Gravity slows time. The deeper you are in a gravitational well, the slower time passes for you relative to someone higher up, further from the source of gravity. This is not a metaphor or an analogy. It is a measurable, verified, physically real phenomenon. The GPS satellites orbiting Earth must account for this effect in their calculations or their navigation. Would drift by miles per day. Time genuinely runs faster in orbit than on the surface of the Earth, and the satellites know it, and their software corrects for it, and your navigation works because of a consequence of Einstein's insight from more than a century ago. Now scale that effect up to the neighborhood of a black hole. For the distant observer watching you fall, as you approach the event horizon, you appear to slow down. Not because anything is physically stopping you, but because the light carrying information about your position and your movement is climbing out of an increasingly deep gravitational well to reach them, losing energy, stretching, arriving more and more slowly. From their perspective, you never quite reach the event horizon. You approach it asymptotically, slowing and dimming and reddening as the light from your body stretches toward the infrared, toward the microwave, toward wavelengths too long and too faint to detect. You fade. You do not arrive. You simply become, from the outside perspective, a ghost of increasing stillness pressed forever against a boundary you appear never to cross. But from your perspective, from inside the falling frame, from the point of view that is yours and only yours as you descend through the geometry of this extraordinary place, the event horizon is not a wall and not a mirror and not a place where time stops. It is simply the next moment. And the moment after that. And the moment after that. You cross it. And the universe does not end. And no alarm sounds. And the stars, compressed now into that shrinking circle above you, still shine. And you are still falling, still breathing, still existing in the only way that any of us ever exist, which is moment by moment, breath by breath, presence by presence, in the continuous and unrepeatable fact of being here. Being here, inside the event horizon now, inside the boundary that the universe has drawn not in ink or stone or fire, but in the pure and absolute language of geometry. You are here, And here is unlike anywhere that has ever existed in the experience of any living thing that has ever moved through the ordinary world of surfaces and seasons and the reliable forward march of days. Take a breath. Let it be slow. Let it move through you the way a river moves through deep country, without hurry, without resistance, finding its own level, following the shape of the land beneath it with a kind of perfect and unhurried trust. Inside the event horizon, something has changed that is so fundamental, so deeply structural, that it rewrites the basic grammar of existence. And it has changed not with a bang, not with a dramatic announcement, but silently, geometrically, in the invisible architecture of spacetime itself. What has changed is the nature of the dimension we call time. In the ordinary world, the world of kitchens and conversations and the sound of rain on windows, space and time are distinct. Space is the three dimensions you can move through in any direction you choose. You can go left or right, forward or back, up or down. You have freedom in space. Time, however, is different. Time is the dimension you cannot choose. You cannot go backward in time. You cannot stop time. You cannot turn around in it the way you turn around in a hallway. Time moves in one direction only, from past to future, and it carries you with it whether you wish to go or not. This asymmetry between space and time is so deeply woven into your experience of being alive that it rarely surfaces as something to be noticed. It simply is. Time flows forward. That is what time does. But inside the event horizon of a black hole, something remarkable and deeply strange occurs. The dimension that was time, the relentlessly forward-moving, irreversible dimension of your experience, trades places with one of the dimensions of space. The radial direction, the direction pointing toward the center of the black hole, the direction that in the outside world was a spatial direction you could choose to move toward or away from, becomes time-like. It becomes the dimension you cannot choose. It becomes the direction that the geometry of spacetime insists you move through, carries you through, the way time itself carries you, without permission asked and without any possibility of refusal. Inside the event horizon, falling toward the center is not a choice. It is the future. Rest with that. Let it move through you slowly, the way cold moves through water, filling every space without force, without hurry. The center of the black hole is not a place you are moving toward. It is a time you are moving toward. A moment you are approaching the way every living thing approaches every next moment, inevitably, continuously, with no possibility of reversal. The singularity at the center of the black hole is not somewhere. It is somewhen. And in this sense, inside the event horizon, the geometry of existence has been turned, quietly and completely, inside out. The directions that feel like space to you, the directions in which you might thrash and push and try to escape, are now the free directions. You can move in them. You can turn. You can orbit and spin and explore. But the direction toward the center, the direction that feels, from the outside, like it ought to be just another spatial choice, is now as unavoidable as tomorrow morning is for you right now, lying here in the warmth of this present moment. You cannot avoid the singularity any more than you can avoid next Tuesday. This is one of the most profound and disorienting things that general relativity tells us about the interior of a black hole. And it was not intuited, not guessed, not invented by a storyteller looking for a dramatic detail. It follows directly and rigorously from the mathematics of curved spacetime, from the same equations that have been tested and confirmed to extraordinary precision in every regime where we have been able to test them. The universe is not obligated to make sense in the terms we find comfortable. But it is, apparently, obligated to be consistent. And the consistency of its mathematics leads us here, to this astonishing place where the future has a location. Breathe. In and out. That same slow tide. Let your muscles soften a little more. Let the back of your skull grow heavy against whatever is supporting it. Let your arms lie still. Let your legs be completely at rest. You are going nowhere tonight except deeper into this extraordinary place, and going deeper requires nothing from you except the willingness to remain present, to remain open, to let the universe show you its strangeness without flinching away from it. Because the strangeness is not something to flinch from. The strangeness is the gift. We live most of our lives inside the familiar, inside the known, inside the comfortable architecture of a world that behaves predictably enough that we can plan a day, anticipate a season, trust that the floor will be there when we step out of bed in the morning. And that familiarity is beautiful in its way. It is the fabric of ordinary life, and ordinary life, attended to carefully, is full of grace. But there are moments when the familiar parts, when the veil of the ordinary lifts just slightly, and something immense and strange and humbling looks back at us from the other side. Standing at the edge of the ocean on a dark night, watching a thunderstorm build on a distant horizon, looking up at a sky clear enough to show the Milky Way in its full, breathtaking sweep, that band of concentrated starlight that is the flat disk of our own galaxy seen from inside, 400 billion stars arranged in a spiral that takes light 250,000 years to cross from edge to edge. In those moments, something in the human body responds. Something loosens. Something that has been holding itself tight and small and defended simply opens, the way a hand opens when it stops gripping something, and for a moment the boundary between self and universe becomes thin and permeable and almost transparent. That is where we are tonight. That is the quality of attention we are moving through this with. Not the attention of examination, not the attention of control, but the attention of surrender, of wonder, of allowing the universe to be as large and as strange as it actually is, without trying to make it smaller, without trying to make it fit. Inside the event horizon, falling toward a future that has coordinates in space. What else is happening? What else is the physics of this extraordinary place doing to the experience of being inside it? There is the question of what you would see. And what you would see, from inside a large enough black hole, in the moments after crossing the event horizon, is something that even the physicists who study these objects find genuinely beautiful to contemplate. The sky above you, the circle of universe that was visible from outside, the compressed and lensed and brilliantly distorted image of the entire cosmos gathered into a shrinking window, is still there. It is smaller now, that circle. It has continued to contract as you have fallen deeper. But it is luminous, extraordinarily luminous, because the light from every direction in the universe is being concentrated into that smaller and smaller angle, making the sky in that direction grow brighter even as it grows more confined. Below you, in the direction of the singularity, the direction that is now your future, there is darkness. Not the warm and ancient dark of open space, which is, if you look at it with instruments sensitive enough, faintly luminous with the cosmic microwave background radiation, the afterglow of the Big Bang itself, a bath of microwave photons that fills the entire universe at a temperature of approximately 2.7 degrees above absolute zero. The darkness below you is different. It is the darkness of a direction from which no light can come, because no light is traveling in that direction from outside. The singularity does not glow. The future, in this place, does not illuminate itself in advance. You are falling toward a darkness that is not empty but inevitable, toward a place where the mathematics of the universe writes its most extreme and mysterious sentence. And like all the most important sentences, it ends in a way that transforms everything that came before it. But we are not at the end yet. We are still falling, still breathing, still moving through the interior of this extraordinary place with the patience and the openness that it deserves. And there is so much more to see, so much more to feel, so much more to understand about what the universe is doing here, in this place where it has folded itself into its deepest and most private configuration. Let your breath come and go without any effort. Let it find its own rhythm, its own depth, the way it always does when you stop attending to it, when you simply trust the body to do what the body has always known how to do. You have been breathing since your first moment. You will breathe all through this night. There is nothing to manage here, nothing to monitor, nothing to maintain. Simply rest inside the breathing the way you rest inside this story, carried along by something larger than any single effort. We should spend some time now with a question that arises naturally from everything we have been exploring. A question that sits quietly at the edge of the physics, patient and unresolved, one of the deepest and most consequential unsolved problems in all of science. A question that connects the interior of black holes to the very nature of information, of reality, of whether the universe keeps records of everything that has ever happened inside it. The question is this: when something falls into a black hole, when it crosses the event horizon and becomes, from the outside perspective, forever inaccessible, forever beyond the reach of any observation or measurement or interaction with the rest of the universe, what happens to the information it carried? Information, in the sense that physicists use the word, means something precise and specific. It means the complete description of a physical system, the position and momentum of every particle, the quantum state of every interaction, the full and exact configuration of everything that makes a thing the particular thing it is, and not some other thing. Every atom in your body right now carries information. The pattern of your thoughts carries information. The precise arrangement of particles that makes you you, and not some other arrangement of matter, is information in this rigorous physical sense. And physics, in every domain that has been carefully examined, obeys a principle called the conservation of information. Information cannot be created from nothing and cannot be destroyed. It can be transformed, scrambled, dispersed across enormous numbers of particles in ways that make it practically impossible to recover, the way the information in an unburned book is transformed when the book burns, scattered across the thermal energy of ash and smoke and heated air. Practically unrecoverable. But theoretically, in principle, with complete knowledge of every particle, still there. Still present. Still encoded in the state of the universe. This is a deep and foundational feature of the physics we know. But black holes appear to violate it. And this apparent violation is at the heart of one of the greatest ongoing arguments in theoretical physics. An argument that has involved some of the most brilliant minds the field has produced, that has generated decades of papers and conferences and revisions and counterarguments, and that remains, as of the present moment of human knowledge, genuinely unresolved. It began with Stephen Hawking. Stephen Hawking, one of the most celebrated theoretical physicists of the 20th and early 21st centuries, a man who spent more than 50 years conducting some of the most important research in cosmology and quantum gravity while living with a progressive motor neuron disease that eventually left him able to communicate only through a speech-generating device, made a discovery in 1974 that changed everything we thought we understood about black holes. He discovered that black holes are not entirely black. They glow. Not with ordinary light. Not with the light of burning matter or fusion reactions. They glow with something far stranger, something that arises from the intersection of quantum mechanics and gravity at the very boundary of the event horizon. The glow is called Hawking radiation, and the mechanism by which it arises is one of the most beautiful and unsettling ideas in all of physics. In quantum mechanics, the vacuum of empty space is not truly empty. The vacuum is a seething, restless, fluctuating field of possibility, in which pairs of particles and their antiparticles are continuously and spontaneously created and annihilated. A particle and its antiparticle blink into existence together, exist for an extraordinarily brief moment, and then meet each other again and annihilate, returning their borrowed energy to the vacuum. This happens everywhere, all the time, throughout the entire universe, and under ordinary circumstances it has no net effect on anything. The particles appear and disappear too quickly to interact meaningfully with the world. But at the edge of an event horizon, something different can happen. If a pair of particles appears at just the right place, right at the boundary, one particle might find itself just inside the event horizon while its partner is just outside. And because the particle inside the event horizon cannot escape, the partnership is broken. The outside particle, finding its partner gone, cannot annihilate and return to the vacuum. Instead it escapes, carrying energy outward, radiating away from the black hole into the universe beyond. And that energy, the energy carried away by Hawking radiation, must come from somewhere. It comes from the black hole itself, from its mass, from the gravitational energy stored in its extraordinary compression of spacetime. The black hole loses energy, very slowly, extraordinarily slowly, for any black hole of stellar mass or larger. The Hawking radiation from a stellar mass black hole is so faint, so unimaginably cold, that it would be billions upon billions of times colder than the cosmic microwave background radiation that fills the universe, essentially undetectable by any instrument we could conceivably build. For practical purposes, for any black hole that exists in the current universe, Hawking radiation is negligible. But it is not zero. And over timescales so vast that the human mind cannot hold them without a kind of pleasant vertigo, over timescales that make the current age of the universe seem like an eye blink, a stellar mass black hole would slowly, particle by particle, quantum by quantum, evaporate. It would shrink. It would grow hotter as it shrunk, since smaller black holes have higher Hawking temperatures, and the radiation would intensify. And at the very end, in the final moments of a process that took longer than a googol years, far longer than any star will burn, far longer than any structure we know of will persist, the black hole would end in a final burst of radiation and be gone. And this is where the information paradox lives. Because what happens to the information that fell in? The matter and energy and information that crossed the event horizon over the black hole's lifetime, the stars that fell in, the gas clouds, the light, the perhaps unimaginable variety of things that contributed their mass to this object across its enormous lifespan, all of that information, in the classical picture of black holes, is locked inside the event horizon, inaccessible, and when the black hole evaporates, the Hawking radiation that carries its mass back out into the universe appears to be perfectly random, perfectly thermal, carrying no imprint of what fell in. The information appears to be destroyed. And if information can be destroyed, if the universe does not keep its records, then something fundamental about the physics we believe to be true is wrong. Either quantum mechanics is incomplete, or general relativity is incomplete, or both, or there is something else entirely, some deeper principle we have not yet found, that reconciles these two extraordinary frameworks of understanding that between them describe virtually everything we know about physical reality. This is called the black hole information paradox. And it is not a minor puzzle at the edges of physics. It is a crack running through the foundations. A place where the two greatest theories in modern science look at each other across the interior of a black hole and find themselves unable to agree on what is happening. Unable to speak the same language. Unable to hold the same reality. And in that inability, in that profound and generative disagreement between quantum mechanics and general relativity, lies perhaps the greatest opportunity in the history of physics. The opportunity to find something deeper. Something that contains both frameworks the way a river contains both the water and the riverbed. Something that explains not just how particles behave at the quantum scale or how gravity curves spacetime at the cosmic scale, but how these two descriptions of the universe, so different in their language and their mathematics and their fundamental assumptions, are actually two faces of a single, unified truth. Physicists call the search for this unified truth the theory of quantum gravity. It does not yet exist. Not in its complete form. not in a form that makes testable predictions across all the regimes where both quantum mechanics and gravity matter simultaneously. But the search for it is the deepest and most ambitious project in contemporary theoretical physics, and the black hole, with its event horizon and its singularity and its information paradox, sits at the very center of that search. Like a locked room in a house that contains, somewhere inside it, the key to everything. Let that image rest with you for a moment. A locked room containing a key. The universe has hidden its deepest secret inside the place that is hardest to look. As if it arranged this deliberately, as if the cosmos has a sense of the poetic, tucking its most fundamental answer behind the most extreme and impenetrable boundary it knows how to create. We cannot go there physically. We cannot send instruments there and retrieve data. We cannot observe the interior of a black hole from the outside in any direct way, because no information from inside the event horizon can reach us. But we can think our way there. And thinking, when it is done with enough care and creativity and mathematical precision, has taken us further into the nature of reality than any physical journey could. Thinking took us to the inside of atoms, to the structure of spacetime, to the moment of the Big Bang, to the quantum fluctuations that seeded the large-scale structure of the entire observable universe. Thinking, patient and rigorous and imaginative, is the most extraordinary instrument humanity has ever developed. And right now, lying here in the warmth and the quiet of this moment, your thinking mind resting, your analytical mind soft and unhurried, you are participating in the oldest and most human of all activities. You are wondering. You are letting the questions be present without demanding that the answers arrive immediately. You are sitting with mystery the way our ancestors sat with fire, not trying to possess it, not trying to extinguish it, simply letting it illuminate the darkness in its own way, in its own time. Breathe. Let the breath be long and easy. Let it slow a little more with each cycle, the natural drift towards sleep beginning to pull gently at the edges of your awareness, like a tide pulling gently at the edges of sand. You do not need to resist it. You do not need to hold yourself awake. Let whatever wants to come, come. The story will continue in the space between waking and sleeping, in that luminous and receptive place where the mind is most open and the universe feels most close. Now, there have been proposed solutions to the information paradox, and they are worth dwelling on, not as technical arguments to be won or lost, but as visions of what the universe might be, as different ways of imagining the relationship between information and reality and the nature of what a black hole is at its most fundamental level. One proposal, developed in the 1990s through the work of physicists including Leonard Susskind and Gerard T. Hooft, is called black hole complementarity. This idea suggests that there is no paradox, not because information is preserved in an obvious way, but because the perspectives of different observers are genuinely, physically different, and no single observer ever witnesses a contradiction. For an observer falling into a black hole, everything proceeds normally. They cross the event horizon and continue to fall, carrying their information with them into the interior. For an observer hovering outside, watching from a safe distance, the infalling observer's information appears to be encoded in the Hawking radiation that slowly escapes. Both pictures are true, and they do not contradict each other because no single observer can ever be in both places at once to verify both pictures simultaneously. The universe, in this view, is not a stage on which events play out identically for every audience. It is something stranger and more subtle. A place where the description of what is happening genuinely depends on who is describing it, and where the requirement for consistency is not that all observers agree on every detail, but only that no single observer ever witnesses a physical contradiction. This is a deeply counterintuitive idea, and it becomes even stranger. In 2012, a group of physicists published a paper that became known in the physics community simply by the name of one of the authors, Ahmed Al-Mhairi, along with his collaborators Donald Merolf, Joseph Polchinski, and James Sully. Their paper is referred to as AMPS, from the initials of the authors, and it presented what became known as the firewall paradox. The AMPS argument went like this. If Hawking radiation truly carries the information of everything that fell into the black hole, as black hole complementarity requires, then the radiation emitted late in the black hole's life must be quantum mechanically entangled with the radiation emitted earlier. This is required by the conservation of information. But quantum mechanics has a strict rule, called the monogamy of entanglement, which states that a quantum system can be maximally entangled with only one other system at a time. And here the contradiction emerges. The late radiation, to carry the necessary information, must be entangled with the early radiation outside the black hole. But the principles of general relativity and the requirement that an infalling observer crosses the event horizon smoothly and without drama require that the same late radiation be entangled with modes of the quantum field inside the event horizon. One system. Two maximal entanglements. Quantum mechanics says this is impossible. Something must give. And what the AMPS authors proposed was that what gives is the smoothness of the event horizon. That instead of crossing the event horizon in the gentle, undramatic freefall that general relativity predicts, an infalling observer would encounter a wall of high-energy radiation at the event horizon itself. A firewall. A place where the quantum requirements of information conservation would manifest as a physical, violent, catastrophic boundary that would destroy anything attempting to cross it. The firewall paradox shook theoretical physics. Because now there were two terrible choices. Either information is lost when black holes evaporate, violating a foundational principle of quantum mechanics. Or the event horizon is not the smooth, undramatic boundary that general relativity describes, but a firewall of destruction, violating a foundational principle of general relativity. Either the quantum is wrong, or gravity is wrong. Or both contain within them something not yet understood, some deeper principle that resolves the contradiction in a way that neither framework alone can see. Physicists are still arguing about this. Brilliantly, creatively, with enormous mathematical sophistication and genuine intellectual passion, they are still arguing about this. New proposals have emerged, each one illuminating some aspect of the problem while creating new puzzles in its wake. Ideas involving quantum error correction, ideas involving the geometry of spacetime being built from quantum entanglement itself, ideas suggesting that the interior of a black hole might not be a separate region of spacetime at all, but rather a different description of the region outside, a holographic encoding of the same information in two entirely different geometric languages. The holographic principle. This is one of the most beautiful and strange ideas in contemporary physics, and it deserves to be approached with the kind of slow and wondering attention that this night, this darkness, this deep and restful state of drifting awareness is perfectly suited for. The holographic principle arose from the work of physicist Jacob Bekenstein in the early 1970s, who made a remarkable discovery about black holes. He found that the entropy of a black hole, the measure of the information content of all the things that have fallen into it, is not proportional to its volume, the way you might expect for an ordinary object. It is proportional to the area of its event horizon. The surface area. The two-dimensional boundary, not the three-dimensional interior. And this seemingly technical observation, this mathematical relationship between entropy and surface area rather than volume, turned out to contain within it one of the most radical implications in the history of physics. An implication so strange, so far-reaching, so fundamentally disorienting in the most beautiful possible way, that physicists are still working through its consequences decades later, finding new layers of meaning the way you find new layers in a piece of music you have heard 100 times and still not fully understood. The implication is this. All of the information contained within a three-dimensional region of space, everything that is happening inside that volume, every particle and field and interaction and configuration of matter and energy, can be completely encoded on the two-dimensional surface that bounds it. Not approximately encoded. not partially encoded. Completely. The interior, with all its apparent depth and complexity and three-dimensional richness, is in some profound sense a projection of the boundary. A hologram. Let that settle over you like something weightless. The word hologram comes from the Greek words for whole and written. A holographic image is one where the complete information about a three-dimensional object is encoded on a two-dimensional surface and can be reconstructed from it. You have perhaps seen holograms, those shimmering images that appear to have depth when you move around them, created by the interference patterns of laser light recorded on a flat plate. They are beautiful and slightly uncanny, these three-dimensional appearances arising from flat surfaces. Now imagine that the universe itself might work this way. Not as a trick of light, not as an analogy, but as a fundamental feature of the relationship between information and geometry, between the interior of a region of space and its boundary, between what is inside and what is encoded on the surface that defines inside. This is the holographic principle. And in the context of black holes, it suggests something extraordinary. It suggests that everything that falls into a black hole, every particle, every quantum of information, every piece of the complete description of everything that has ever crossed the event horizon, is encoded on the event horizon itself. Not inside. On the surface. On that two-dimensional boundary that separates the interior from the exterior, written in the language of quantum entanglement and quantum information in a script we do not yet fully know how to read. The interior of the black hole, in this picture, is not a separate place where things go and are lost. It is a projection, a three-dimensional holographic reconstruction of information that lives, completely and permanently, on the event horizon's surface. And if this is true, then nothing is ever lost. Nothing is ever destroyed. The information paradox resolves not because information escapes in Hawking radiation in a way we can directly trace, and not because some new force prevents things from crossing the horizon, but because the interior and the boundary are not two separate things. They are two descriptions of one thing. Two languages speaking the same sentence. Breathe slowly, in and out. The long, easy rhythm of a body that is almost at rest, almost at the shore of sleep, drifting in the warm shallows where thinking becomes dreaming and dreaming becomes something softer still. You do not need to hold any of this tightly. You do not need to remember the names or the dates or the precise formulations of any of these ideas. What matters tonight is not the content of the knowledge, but the quality of the encounter. The felt sense of standing at the edge of something vast and mysterious and genuinely, deeply unknown. Because that unknowing is not a failure. It is an invitation. The universe has arranged things so that its deepest secrets are hidden behind its most extreme conditions. So that to approach the truth about what happens inside a black hole, we must push ourselves to the very limits of our mathematical and conceptual tools, must develop entirely new ways of thinking, must be willing to let go of assumptions so fundamental that they feel like the ground itself. And in that process of letting go, in that willingness to release what we thought we knew in order to reach toward what we do not yet know, something remarkable happens. We grow. Not just as scientists, not just as physicists building better theories and sharper mathematical tools, but as conscious beings inhabiting a universe that turns out to be stranger and more generous and more intricate than we imagined. Every time we have looked directly at one of these deep mysteries and refused to look away, refused to settle for a comfortable but incomplete answer, the universe has shown us something new. Something that enlarged the picture. Something that made the world more interesting and more beautiful and more worthy of the attention we give it. The holographic principle did not remain a speculation about black holes alone. In 1997, a paper that is now one of the most cited physics papers ever written. In it, he described a precise mathematical correspondence between two entirely different theories. On one side, a theory of quantum gravity in a particular kind of curved spacetime called anti-de Sitter space. On the other side, a quantum field theory with no gravity at all, living on the lower dimensional boundary of that space. These two theories, one describing a world with gravity and one describing a world without it, one living in the bulk of a spacetime volume and one living on its boundary surface, were shown to be exactly equivalent. Not approximately equivalent. Not equivalent in some limited regime. Exactly, completely, mathematically equivalent. Every calculation you could perform in one theory has a precise counterpart in the other. Every physical question you can ask in the gravitational theory has an answer in the boundary theory, and vice versa. This correspondence is called the AD/CFT correspondence, or sometimes simply the duality. And what it means, in the broadest and most profound sense, is that gravity itself, the curvature of spacetime, the very architecture of the universe at the largest scales, can emerge from quantum entanglement, can be built from it, the way a three-dimensional image is built from the interference patterns on a two-dimensional holographic plate. Gravity is not fundamental in this picture. It is emergent. It arises from something deeper, from the quantum information structure of the boundary theory, the way wetness arises from water molecules even though no single molecule is wet. The geometry of spacetime is woven from quantum entanglement. This is perhaps the most beautiful idea in contemporary physics. And it changes how we think about the interior of a black hole in ways that are still being worked out, still being understood, still yielding new insights with each passing year as physicists learn to translate more questions from the language of gravity into the language of quantum information and back again. In this picture, the interior of a black hole is not a mysterious sealed chamber into which things disappear. It is a region of spacetime whose geometry is constructed from patterns of quantum entanglement, patterns that are encoded in the Hawking radiation that slowly escapes, patterns that persist and evolve and are in principle recoverable, though in practice scrambled with a thoroughness that makes any actual recovery essentially impossible with any technology we could conceive. But in principle, in the deep, mathematical, structural sense of in principle, the information is there, woven into the radiation, written on the horizon, encoded in the entanglement, present in the universe in some form, even when the black hole itself has long since evaporated into the cold and ancient dark of a cosmos that has aged beyond all recognition. Nothing is lost. The universe remembers everything. Let that be a comfort, somehow, in whatever way feels true to you tonight. The universe is not careless with what it has been given. It does not throw things away. It transforms, it scatters, it redistributes across scales and forms and configurations that bear no resemblance to what came before. But it remembers. In the language of quantum states and entanglement and the precise mathematical structure of its own laws, it keeps its records with a fidelity that is, in the most literal physical sense of the word, perfect. And you are part of what it remembers. The atoms that make up your body have been part of this universe for nearly 14 billion years. They have been inside stars. They have been scattered by supernovae. They have drifted through interstellar clouds and been gathered by gravity into new solar systems and rained down onto new planets and become, eventually, improbably, miraculously, part of a living thing complex enough to lie here in the dark and wonder about black holes and the nature of information and whether the universe keeps its promises. And it does. Not in the way that promises are kept between people, not with intention or care or the warmth of a relationship between conscious beings, but in the way that mathematics keeps its promises, in the way that the laws of physics, operating without exception and without preference across every corner of the observable universe, maintain their consistency from the first moment of the Big Bang to the last slow cooling of the final stars. The universe keeps its promises the way a river keeps its promise to reach the sea. Not because it chose to, because it cannot do otherwise. Because the nature of what it is makes certain outcomes not merely likely but inevitable. And there is something in that which, if you let it, feels like rest. The universe is not improvising. It is not uncertain about its own rules. Whatever mystery remains about the interior of black holes, whatever questions the information paradox has not yet fully answered, whatever gap still exists between quantum mechanics and general relativity waiting for the theory that will bridge them, the universe itself is not confused. The universe is doing exactly what the universe does, with complete consistency, in every location and at every scale and across every moment of time, from the earliest fractions of a second after the Big Bang to the incomprehensibly distant future that awaits. It knows what it is doing, even when we do not yet know what it is doing. And that is enough. That is more than enough. That is, in fact, one of the most restful things a human mind can contemplate, lying here in the dark with the breath moving slowly and the body completely at rest. The universe is coherent. It is consistent. It is, in the deepest sense, trustworthy. And we are inside it, made of it, carried by it, the way a wave is inside the ocean and made of the ocean and carried by the ocean, distinct for a moment in its particular form and then dissolved back into the larger movement, the larger pattern, the larger continuity that was never really separate from it at all. Let your body sink a little deeper. Let the surface beneath you hold a little more of your weight. Let the breath be a little longer, a little slower, a little more automatic, and a little less attended to. Sleep, if it wants to come, is welcome. The story continues in the dark, in the space behind closed eyes, in the territory that is neither fully waking nor fully sleeping but something between, something that the human nervous system visits every night and that has no precise name in ordinary language but that you know in your body as a kind of homecoming. We have been traveling for a long time tonight. We began at the beginning, with the simple instruction to close your eyes and let the weight of the day dissolve. We moved through the nature of stars, through the violence and beauty of their deaths, through the formation of black holes from the collapsed cores of massive suns. We stood at the event horizon and understood what it means for a boundary to be defined not by material but by geometry. We fell through it, felt the strange and quiet way it yields to the falling body, and discovered on the other side that the dimension we call time has traded places with the dimension we call space, so that the future has a location and moving toward it is as involuntary as the next heartbeat. We visited the information paradox, that deep and unresolved tension between quantum mechanics and general relativity, between the principle that information cannot be destroyed and the apparent implication that black holes destroy it. We met Hawking radiation, that faint and extraordinary quantum glow at the edge of the event horizon, the black hole's slow and patient exhalation into the universe over timescales that dwarf the current age of the cosmos. We explored the firewall paradox and felt the weight of the contradiction it contains, the place where two of our greatest theories look at each other and cannot agree. And we arrived at the holographic principle, that breathtaking idea that the interior of a black hole, perhaps the interior of any region of spacetime, is encoded on its boundary surface. That the three-dimensional richness of what we experience as inside is a projection, a holographic reconstruction, of information written in 2 dimensions on the surface that contains it. That gravity itself may emerge from quantum entanglement the way a solid object emerges from the dance of its constituent atoms, real and substantial and physically effective but not fundamental, not the deepest layer, not the bottom of the well. These are the ideas that live at the frontier of human understanding. These are the questions that keep physicists awake at night, not with anxiety but with the particular and electric restlessness of people who have caught a glimpse of something extraordinary and cannot stop thinking about it. The best physics feels like that, like catching a glimpse of something through a gap in the trees that you cannot quite identify, something large and extraordinary and alive, and knowing that if you can just find the right path through the undergrowth, if you can just find the angle of approach, you will see it whole. We have not seen it whole yet. The theory of quantum gravity, the complete and unified description of how quantum mechanics and curved spacetime fit together, has not yet been written. The precise mechanism by which information escapes a black hole, or is preserved on its horizon, or is encoded in Hawking radiation in a recoverable form, has not yet been fully understood. The nature of the singularity at the center, that place where the mathematics breaks and the equations confess their incompleteness, remains genuinely, profoundly mysterious. And this is, in the most sincere sense, wonderful. Not wonderful in a polite or performative way. Wonderful in the original sense. Full of wonder. A state in which the mind has encountered something it cannot fully contain and has responded not by retreating into the familiar but by expanding, quietly and organically, to make more room for the mystery. You contain that capacity for wonder. It is one of the most distinctly human things about you. The ability to hold a question that has no current answer and find the holding itself valuable, find the sitting with the mystery nourishing rather than frustrating. Children do this naturally. They ask why, and when the answer generates a new question, they ask why again and again, following the thread of inquiry down into depths that adults often find uncomfortable because the adults have learned, somewhere along the way, that some questions do not have answers yet and have mistaken that fact for a reason to stop asking. But the questions are the thing. The questions are where the aliveness is. And tonight, lying here in the dark with the universe spread out above and around and through you, with the atoms of your body vibrating at temperatures that place you far, far above the near absolute zero of deep space, with the chemistry of your brain producing the quiet and extraordinary phenomenon of consciousness, of experience, of the felt sense of being here and being aware of being here, you are the universe asking itself questions about itself. That is not a metaphor. That is, as far as we can determine, literally what is happening. The universe, through the improbable instrument of the human nervous system, has become capable of wondering about its own nature, of building telescopes and mathematics and theories and arguments, of sending radio signals across interstellar distances and detecting, with instruments sensitive enough to measure a change in length smaller than a proton, the gravitational waves produced by two black holes merging more than 1 billion light-years away. That detection happened in September 2015. For the first time in history, humanity felt the universe move. Two black holes, each roughly 30 times the mass of our Sun, had been spiraling toward each other for billions of years, their mutual gravity drawing them closer in an accelerating in spiral, radiating gravitational waves as they went, ripples in the fabric of spacetime spreading outward at the speed of light. In the final fraction of a second before they merged, they were radiating more power than all the stars in the observable universe combined. The collision produced a single, larger black hole, and the energy equivalent of 3 solar masses was radiated away as gravitational waves in that final fraction of a second. 3 suns, converted entirely to ripples in spacetime, in less than a second. And those ripples, diminished by 1 billion light-years of travel, stretched and compressed the detectors of the LIGO observatory by a distance 20 times smaller than the nucleus of a hydrogen atom. And we felt it. We built something sensitive enough to feel it. We translated that almost incomprehensible whisper in the fabric of spacetime into a sound file that lasts a fraction of a second, a rising chirp, and we played it through speakers and heard, for the first time, the universe speak in a language older than light. A chirp. A fraction of a second. The sound of 2 black holes becoming one, translated from the geometry of spacetime into pressure waves in air, into vibration in the tiny bones of the human ear, into electrical signals in the auditory nerve, into the experience of hearing. The most extreme event in the known universe, processed through the most intimate and ordinary of human faculties. We heard it the way we hear birdsong, the way we hear rain, the way we hear a voice we love calling our name from the next room. The universe spoke and we were listening. And what it said, in that fraction of a second, in that rising chirp that contains within it the record of billions of years of inspiral and the violence of merger and the birth of a new and larger darkness in the fabric of spacetime, what it said was something we had suspected and something we had calculated and something we had worked toward for decades, but had never, until that moment, actually heard confirmed in the language of direct experience. It said that black holes are real, not theoretical, not mathematical conveniences, not solutions to equations that might or might not correspond to anything in the actual universe. Real, physical, present in the cosmos in numbers we are only beginning to count, in sizes we are only beginning to map, in a variety and a distribution throughout the observable universe that makes them not exotic exceptions but fundamental features of the landscape of reality. Black holes are part of the universe the way mountains are part of the earth, the way ocean trenches are part of the sea. They are built into the structure of things, consequences of the same gravitational physics that holds planets in their orbits and keeps your feet on the ground and draws the tides across the face of the ocean every day of every year of every century of the long human story on this small and beautiful world. We are not separate from them. We are downstream of them, in a sense. The supernova explosions that seeded space with the heavy elements that made planets and oceans and living things, those explosions happened because stars collapsed toward the conditions that make black holes possible. The iron in your blood was forged in the core of a star that died in exactly the process we described tonight, a core collapse that in many cases produces a neutron star and in others, where the mass is sufficient, produces a black hole. You are made, in part, of the processes that make black holes. You are kin to the darkness, not in a frightening way. In the way that all things in the universe are kin to all other things in the universe, because everything arose from the same initial conditions, the same first moments, the same primordial fireball of energy that became, over nearly 14 billion years of expansion and cooling and gravitational collapse and nuclear fusion and chemistry and biology, everything that exists. Every star and every planet and every ocean and every living cell and every thought that has ever moved through any mind anywhere in the cosmos. One origin, infinite variety, and within that variety, black holes. These extraordinary, extreme, boundary-defining objects that sit at the limits of what physics can currently describe and point, with the quiet authority of mathematics, towards something beyond the current description. Something deeper. Something that we have not yet reached, but that we are, with each generation of physicists and each new instrument and each new idea, getting closer to. The journey we have taken tonight will not end when you wake tomorrow. It does not end when the last word of this narration fades into the quiet of your room. The questions we have visited, the strangeness we have allowed ourselves to inhabit, the wonder that has been moving through you as we drifted through event horizons and singularities and Hawking radiation and holographic principles and the sound of two black holes becoming one, all of that continues. It continues in the research being done right now by physicists at universities and observatories and research institutes all over the world. It continues in the data being gathered by instruments pointed at the centers of galaxies, listening for the signatures of the objects that anchor them. It continues in you, in the part of you that will carry something of tonight forward, some residue of the encounter with these ideas, some faint and persistent impression of having been in the presence of something genuinely vast. The way you carry the residue of a dream that you cannot fully remember, but that has left a quality of feeling, a tone, a color at the edges of the day that follows. Let your breath be very slow now. Let it be almost imperceptible. The long, deep, automatic breathing of a body that is truly at rest, truly surrendered to the night, truly released from the effort of holding itself together against the day. You have been held tonight by something much larger than anything you needed to manage or maintain. The universe has been doing what it does, enormous and consistent and patient and indifferent in the most profound and beautiful sense of that word, and you have been inside it, resting inside it, a small and extraordinary piece of it taking a few hours to be still. The black hole at the center of our galaxy is turning, right now, in the dark. Sagittarius A*, 26,000 light-years from where you are lying, is doing what it has been doing for billions of years. Its event horizon, that sphere of geometric inevitability, is present and unchanged and absolute. The stars that orbit it are completing their long, elliptical paths through the central region of the galaxy. Gas and dust and the remains of ancient stellar explosions are drifting in the space around it, some of it fated to fall in, some of it carried away by the powerful forces that operate in the galactic center. It is all happening, quietly and continuously, while you sleep. The gravitational waves from merging black holes in distant galaxies are passing through you right now, stretching and compressing the space you occupy by distances so small they make the nucleus of an atom look enormous. You do not feel them. Your body cannot register them. But they are there, rippling through the fabric of spacetime that your matter inhabits, a constant and unceasing conversation between the most extreme objects in the universe conducted in the geometry of space and time itself. You are bathed in it. You are always bathed in it. The universe is not quiet. It is roaring at every frequency and in every medium, with the accumulated energy of nearly 14 billion years of activity. Gravitational waves and electromagnetic radiation and neutrinos and the cosmic microwave background and the solar wind and the light of a trillion stars, all of it passing through this room, through these walls, through the body lying here in the dark, through the mind that is now drifting, softly and irresistibly, toward sleep. And somewhere in that roar, inaudible and yet somehow present in the quality of the night, is the sound of the universe thinking about itself, working out its own nature, pressing against its own limits and finding, in that pressure, the shape of questions it has not yet answered. The shape of a locked room that contains a key. The shape of an event horizon that hides its interior from every eye and every instrument except the one that does not yet exist, that will be built by minds not yet born, in a future not yet arrived. We are in the middle of the story. We are always in the middle of the story. And the middle of the story is exactly where the living happens. Not at the beginning, where everything was simple and undifferentiated and nothing had yet become anything. Not at the end, which is too far away and too cold and too quiet to dwell on tonight. Here, in the middle, where stars are still burning and black holes are still turning and the universe is still expanding, and on a small, warm, water-covered planet orbiting an unremarkable star in a quiet arm of a spiral galaxy, conscious creatures are lying in the dark and wondering what happens inside a black hole. Wondering is enough. Wondering, tonight, is everything. Let the darkness be soft. Let the questions be present without demanding answers. Let the universe be as large as it is, and let yourself be as small as you are, and let the distance between those two scales be not a source of insignificance but a source of the deepest possible awe. You are small and you are here and you are conscious and you are wondering, and that is the most extraordinary thing that the universe has managed to produce in nearly 14 billion years of trying. Rest now. The black holes are turning. The stars are burning. The gravitational waves are moving through you like breath through a sleeping body. The universe is keeping its records with perfect and absolute fidelity, writing everything that has ever happened into the quantum structure of spacetime itself, forgetting nothing, losing nothing, holding everything in the vast and patient and luminous dark. You are held. You are remembered. Sleep.